Okay, now, today, here we go. Today we have what's referred to as a point of tangent. All right. Now, to me, personally, I feel like they should have just given us a different word because we already use tangent to mean the opposite side over the adjacent. All right. But there is another definition for tangent, and it just means that a line or a segment is tangent to a circle if it touches the circle at exactly one spot. All right. So if you look up, please, SR right here is considered tangent to that circle because it touches it at point R. All right. It doesn't go through something like this and say, haha, it really went through twice. Everybody see what I'm getting at? Yeah. All right. So when somebody says point of tangency, sometimes if you blow it up, it may look like it is or it isn't. All right. Well, if they say it's a point of tangency, that just means it touches it at one single point. All right. So this up here would be considered a secant line. All right, which is also a trig function as well that you'll learn later on. But secant just means it goes through the line twice. That's it. You have a tangent line and you have a secant line. All right. And then we're going to learn a few things about the relationships between tangents and secants. All right. So that R is considered a point of tangency. All right. Now, here we go. A common tangent is a line, array, or segment that is tangent to circles in the same plane. All right, now what in the world does that mean? And I don't think we're really ever going to need that. But what they'll mean is something like this. Well, that's not very good, but we'll do this. All right. So that's a common tangent. All right, that's a common tangent. All right. Now, I believe they also say that is considered externally tangent. Now, look, you guys are being very distracted with the food. I'm just letting you know. All right. That is considered externally tangent. And the reason why they call that externally tangent is because if you draw the centers of the circle and you connect them, it does not intersect that tangent. All right. I can also draw this right here. Well, that's not a very good angle. Watch here. Watch this. Hold on a minute. This line right here is called internally tangent. All right. So externally tangent, the line connecting the two centers does not touch the tangent line. This is considered internally tangent because it passes through that line. Does everybody understand that? All right. It's not really even a big deal. All right. But it's just a minor thing. All right. So now let's figure out some of the properties here. What seems to be true here? All right. If you draw from the radius to the point of tangency, what type of angle is created? Yes. Again, you can kind of look at that real quick and see. So anytime you have a point of tangency, all right, and you draw the radius to the point of tangency, it creates a 90-degree angle. Yes. No, PR is not tangent. That would be a radius. It could also be considered, no. Well, actually, that's actually a very good observation, but the line has to be, or the segment has to, yeah. All right, that's a good question. Go.
If S was like higher, when it created like a point S is higher.
Absolutely. So let's do that. That's part of the reason why I really kind of like the iPads for the demonstrations. So let's do this. So let's make S, you say a little bit higher, correct? Now watch what happens. Is it a tangent line anymore? You see what I'm saying? It's not a tangent line anymore because it would touch at two spots, not at one. You see what I'm saying? So, and this is kind of something which I think he was referring to. Watch. That is not a tangent line. Just because it stops at the circle. You with me on that? All right? Because it's a tangent line. All right? Which means it continues on. Very good question so far. All right? Now, again, if I do this, watch real quick. If I were to draw from P to T, guess what angle is created? Yeah, did everybody see that? All right. The angle. The angle is created. If T is a point of tangency, that is a 90-degree angle. All right. Now, what's true about RS and ST? They're equal. Right? And how do we know that? Well, it wouldn't be hard to prove, right?
Oh, because they're,
Yeah.
yeah.
Exactly, right? So we could say this is equal to this because those are both what? Radii, right?
Yeah.
Those are radii. And then PS is congruent to itself, right? And then we have, well, but in this case, yes, it actually, we would say it's hypotenuse leg, where when you have a right triangle, if one leg and a hypotenuse are congruent, then the triangle itself is congruent. All right, yes.
You said that if it was like just a line coming and it stopped at the circle, that's not.
Right. So I'm changing.
But it also says that a tangent can be with a line, ray, or segment. So if it was something like a segment or ray, so the line that came and stopped at the circle would still be.
Very good question also. RS is considered a segment. It's tangent. Does that make sense? Right. Just because I stop here, again, guys, very good question. Just because I stop there, that's not a tangent. All right. I think it means, I think the better definition would be if you extend it. Right. It has to be an extension. All right. So you could have a ray, like you could just make RS a ray, and that would still be a point of tangent. And if you extend it on the other side, there's no way for it to circle again. All right. Those are actually very good questions. All right. So here, does everybody see, or can everybody kind of picture those are the same? All right. So it doesn't matter where your line, where your point is outside the circle. If you draw a point of tangency right there, I'm trying to draw from here to a point of tangency over here. What's true? Yeah, they're equal. Right? And hopefully it's pretty easy to see because you would just draw from the center to there. Then you would draw here. Then you would draw here. And in fact, somebody said it makes a what? Yes, that's a right angle, but the shape itself is a kite. Do you agree with that? All right. So again, very, very simple. Very simple. All right. And I used to tell kids all the time, especially on these, if it looks true, guess what? It is true. All right. So, number one, x is what? 4. X equals 4. All right. Over here, somebody tell me what that is. Mental math, everybody. Good. So what would it be? 25. Very, very smart, bro. X equals 25. How did she know that so quick? Somebody, 3, 4, 5, right? Again, on the SATs, right triangles, Pythagorean triples are always on there. All right, so make sure you know that. That wasn't that hard. All right, so let's look at number 3. That's easy, 12. Number 4, do we know the triple there? 5, 12, 13, so it would be 39. Everybody good with that? Right, it's very, very easy if you know your triples. 39. Let's carry on here. Oh, now this one's kind of nice. AB is 8. So how do I do this? Someone who's thinking. So what is YB?
The radius. YB is 29.
Right, very good. Very good. So this right here is what? 29. All right. So now take out your calculator. And tell me what this is. I think it's another triple, but we don't use this very much.
20.
Is it 20? Right. Double check him, please, because he made a couple mistakes last week. Everybody good? Come on now. Type it in on your calculator. 29 squared minus 21 squared equals... All right. Thank you. All right, so now let's take a look at... yeah. I don't think that's... Do it. Do it on your calculator.
Yeah, that's right. 29.41.
All right, 29.41. So what's 17 squared plus 24 squared?
865.
Square root of 865. We're practicing, guys. We're going to keep it as a radical. So divide that by 5 for me. Somebody tell me what that is.
172.
I'm not sure 173.
It's just radical.
Yeah, break it down. Right. So square root of 865. All right. Everybody agree that's kind of easy, right? Very easy. All right. All right, so now here, let's look over here at this example right here. Somebody tell me what BD is. What is EC? And what's AD? 12. Right. Sometimes they're going to ask you about the inscribed circle or the perimeter of the triangle. Yeah.
So, is this the same as the first one? So the first one, the two things are equal. So they're not equal, but they're like the ratios are the same. All of the
So A right here,
Mhm.
if we were to draw this from here to here, is equal to that. Do you agree? It just so happens that if I extend the point of tangency here, and I extend it to here, you see what I'm saying? We're not saying that AB has no relationship to AC, right? But this is equal to this, plus this equal to this, and these are equal. All right? I think it's pretty straightforward. All right? So let's look at number 1 here. So what is X? Everybody happy with that? And if you wanted to, you could just put 13 over here and 17 over here. And what? 10 here. All right. Question number 2. Yeah, because this guy right here would be what? 18, which would make that 8, which would make that 8. This would be 14. Very good. Yeah, pretty easy, right? X equals 4. Number 4.
10.
Yeah, correct with that. This has to be 6. This has to be 4. Easy, right? And then over here. What we got? Are we supposed to find the... Yeah, so over here, guys. This is x equals 6. But I knew there had to be something more. They also want the perimeter. Alright. Yeah. Yeah. So, yeah, that makes it much more difficult. Just gotta add. Alright, move forward. Alright, let me see if there's anything difficult. No, nothing is difficult. Alright, your job now, please, is just knock out. Actually, and the ones that are kind of fun are obviously the word problem. Alright, try those. No, try them all. But the word problems you're going to like. Alright? Those are fun. Especially the rolling wheel. Number 4. Alright. Have fun.
Thanks.
You're welcome. You're busy, guys. Again, now remember, listen, get the work done now. Get the work done now. It's not that hard. Plus, if you have a question, I'll try to help. Alright? Yes.
How do you do something not?
Pass it. Oh. If it doesn't intersect at the right angle. Alright, when you draw the radius, it doesn't intersect at the right angle. What?
Not